I wrote too much of my data? She said, yes. I said, okay.
Yeah, it has to be because when I was talking about
All right, so let's keep going down this road and get to the point where you can actually, kind of see it in action. So we're gonna kind of give some hypotheticals around each of these different, factors that would, increase or decrease your chances of rejecting the null, okay? And again, this is before we run the test. So that we just have a general idea of kind of what's going on. Okay, so Shivai is gonna go ahead and be the first one that goes out and does all of the, sampling. She's running around the street, collects all her information, and she finds out that the average height of the people that she interviewed is, I thought it came up here. The dashed line is Shivai's sample, so it's slightly bigger because 67 is 5'7" is here, this solid line. And her sample is slightly bigger. Now, here is a histogram of this sample. Okay, it's a histogram of the sample she's collected. Looking at that histogram, she's got a pretty big sample. She's got a lot of observations. What do you think she would be? Do you think that she would reject or not reject her null that people are 5'7"? Looking at that distribution and looking at her average.
So her average is the black line?
The dotted ball, the solid one is the one associated with 5'7". Guess we should put that in there.
So she's the dotted line,
Yeah,
not project.
she's the dotted line.
project.
Okay, so Shivai goes ahead and gets a significance level of 5%. She runs her test statistic, given this data. Okay, she computes her t-statistic in this manner here. So she computed the sample mean. She takes this difference, divides it by the standard deviation, and finds out that the p-value associated with that is 0.04. Which one? Which one is she in?
The first one.
0.04 is smaller than 0.05. Dion, you said first one, right?
Yeah.
And so because she's further out than she needs to be able to have evidence, given that she wants at least 5% significance, she would then reject the null hypothesis at 5%. How big of an alpha, excuse me, how small of an alpha could she get away with and still reject? Her p-value is 0.4, is 0.04. She started with this. Could she get away with 0.045?
Yeah.
Yeah. And someone may think of it that way. So my p-value on my t-statistic tells me how far I can push the boundary. And that's why, for me as a reader, I don't want to know, what the significance level is. I want to know the p-value so that I can step back and say, hey, I'm not seeing enough evidence here because my significance level in my world is 0.01. And if it's 0.01, am I accepting, or am I not rejecting, or am I rejecting? So if my alpha significance level was that, and this is what Shivai gave me, what would I tell her? You don't got enough evidence. I'm out here, you're here. for me, because I want more evidence, I'm not willing to make those type 1 errors. I would have a different conclusion than she would. Because she only requires a 5%, whereas I want to have a 1% type 1 error. Is that? Okay, so she rejects the null, whereas I cannot reject the null because I want more evidence. Okay, now Taylor, Brianna, and Leah are gonna conduct their own sample. So here's Shavi. And I'm gonna have Taylor, Leah, and Brianna. And they're gonna have similar size, okay? Or, and let's see what their random sample looks like. Okay, so here's Taylor's. And again, the solid line is the null, in other words, 5'7". The dotted line is their sample mean from the sample they've drawn. And you can see how they differ. Let's look at Leah's. What can you tell me about Leah's sample size?
It's long.
It's really small. She only talked to like 10 people. Shavi is talking to like 100 people. And so for Leah, is there a lot of information there?
No.
No. And so in her case, she's probably not even at the 10% significance level would she reject the null. Because she's got people way out here, but in general, there's just not a lot of information. And so it's really this thing here that's so big that's creating a problem for her. If this thing gets big, what happens to the number? It gets really small. And so you're not getting a large t statistic, and hence you're getting a very, very large p-value. So in this particular case, Leah's p-value would be really big, right? And we want it to be small relative to our alpha, our significance level. What about Brianna? Well, do you think she would be rejecting or not rejecting the null? She would be rejecting most likely. Why? Because the people that she sampled are way, way, way in the right-hand tail of tall people. And they're all located. Sure, she found a couple of short people relative to the 5'7", but she's got a bunch of 6-footers and higher out here. So it's pretty likely that she would reject the null. What about Taylor? Taylor's got a really tight distribution right around the null. So it's probably likely that she's not going to reject the null. Right? Because everyone seems to be right there. There's just no one that's pushing her out to the other side. Okay. I think we've all talked about this. All right, so here's what my R output looks when I run a t-test on the data in this particular case. So here's Shavai's case. Okay. She's taking her data, and this is her null. Mu is equal to 67 inches, which is 5'7". Okay, and that would be the command in R that she would run. She hits control return. This is a t-test. This is a t-statistic, 2.07, which is this thing right here. it tells you the degrees of freedom that it's using in its calculation. But the p-value here is, as we said before, is 0.04. So if she has a 5% significance level, she can reject. She has a 1% significance level, she cannot reject. And then down here, you'll see that it gives you a 95% confidence interval and also calculates the mean of where she's at. So she's not that, the value is not that much bigger than 67. But in her particular sample, things are so tight and has so many observations, she has enough evidence at least a 5% significance level to reject. Even though she's just barely an inch taller, right? Whereas in Taylor's case, when we go ahead and put it in, she has a t-statistic of 3.7. The p-value, what's the smallest significance level that you could get away with in Taylor's sample and still reject? Can I reject at 1%? This value is smaller than 1%, right? Way, way smaller. I could get down to, you know, 0.1%. So I'm not gonna go there, but if I see a number like that, 0.0004, that's a lot of evidence against the null. Very little likelihood that I would actually be rejecting the null when the null is true. That's what that's saying. And so, and why is that the case? Well, look at Taylor's. She's got this really tight distribution. That means that this is a really small number. When this is a really small number, it makes this thing big. That's why she's getting so much information against the null here. And so I just look at the distribution and I kind of guess it. And then I actually run it and I say, oh yeah, this is what I would have expected. Now let's okay, so we already kind of said something about Leah's sample, right? And then compared to Chevai's sample, let's see what happens here. In this case, it was the sample size, right? You didn't have many, Leah didn't really measure that many people. And as a result of that, her n here is fairly small. And a small n here gives you a lot of variance, where Chevai's, you know, kind of where we thought. It's still pretty, as I've said before, it's still pretty uniform and spread out. Okay, nothing changes on the right-hand side. Chevai's output is exactly the same as what we saw when we compared it to Taylor's. But when we compare it to Leah's, we said earlier that we probably would find that Leah couldn't reject, right? And if we come in, the t-statistic associated with her data is 0.67. That thing is like almost on 0. So, and the p-value associated with is 0.5. Again, this is normally distributed. 0.5 is 50%. 50% is that side of the distribution. And so you know that she would have a really hard time rejecting this null hypothesis that people are on average 5'7", right? Does that make sense? Okay. And then we see in comparison to Chevai's, you know, it is what it is, okay? So fails to reject, Chevai can continue to reject. Then the less fill-in variability problem, okay? Brianna's sample of people, like I said, she ran out and just simply gravitated towards all those people that were over 6 feet tall. That's the only people that, you know, would stop and let her measure them. Yeah, there was maybe a couple down here that were smaller, but all these people on average were 6 feet tall and pretty tightly distributed to it. And so what's interesting is how tight that distribution is relative to Chabai's spread out uniform kind of distribution. So like we said earlier, you probably reject this because this is a pretty upwardly, on average, a pretty tall sample. So what does the output from R tell us? Well, in this case, as you would expect, the T statistic, because this thing, the numerator is giant, because this average is like 6 feet tall. So that's the part that, plus the lower part, the denominator, is really tight, so this thing's really small. So both the numerator and the denominator are making that T statistic giant. And so that's why you're seeing a T statistic of 14%. And look what the p-value is. Do you know what this means? That is basically 0. It's so far out here in the tail, it just doesn't even measure. The T statistic is so far out here, we're not getting anything. And so she could reject the null. Brianna could reject the null at 5%, 10%, 1%, 0.5%. There's just, in her sample, no one was even close to being 5'7". Okay. All right. So that was our two-sided one group test, where we have a null that they're equal and an alternative that they're not equal. Now we're going to look at this FINRA financial survey data. And what they do is they go out and they ask people in the US, what their financial state of the world was. Think about it in terms of, your financial situation. Are you well off? Are you not well off? Do you have a lot of bills that you can't cover it? Things like that. And it's on a scale from 1 to 10, where 1 is I'm really unsatisfied with my financial state, and 10 is bliss point. I can't, couldn't be better. And we want to be able to say, what is the current level of financial satisfaction on average in the US. And we're going to use the data in this survey to make some inference about the level of satisfaction. So it says here the average level of satisfaction with one's financial state was 5.75. That was the average. You can find that by just running this command on your FINRA clean data, pull out the satisfied variable, run the mean, and you get the 5.896. Okay, this is the frequency. So this is kind of the number of a histogram on each bin. You can see that there's a lot down here at 1. In fact, that's the largest response is under 1. Oh, not quite. 7 is an 8 or bigger. So you got kind of a big group here and then a big group down here. So you're either doing poorly or you're doing quite well. And that's what the distribution looks like. The histogram, the empirical distribution. And the summary statistic, the sample mean is 5.7. So if we come back and we say, okay, is the average level of financial satisfaction in the US different than 5.75? That could be a hypothesis. Is this sample mean of 5.71 significantly different than the sample mean? Than 5.75. Okay. So again, this is how you formulate your null. That then is really the alternative that you should focus on. It's how you want to think about the question. put it into the alternative, and then the null follows. Choose your significance level, we kind of talked about that. You can just go ahead and compute the test statistic and then think about that p-value coming from the test statistic relative to that alpha. Okay, and then make a decision on whether or not you reject or fail to reject the null, given that. Okay. So in this particular case, it was that you are wanting to test and see whether or not the average level of satisfaction in the US is different than 5.75. That's what you're after. You want to know if financial satisfaction is different from 5.75, and so that's your null, and then, excuse me, the alternative, and then the null is that is 5.75. We're gonna go ahead and use a 5% significance level. We're gonna go ahead and run the test statistic, or the command tstat, or t-test. If you hit the help function, it takes a variable name, which is a series, and then mu is equal to, in this case, the null of the hypothesis, so it'd be 5.75. And that's what you see here. This is the data, the series, and this then specifies what the null hypothesis is. So,
Mark, on this one kind of, we've been doing a lot of stuff in tidyverse up until now. The t.test is like an old kind of base R type function. And so we're not gonna be able to use the neat and clean tidyverse way we've been piping things through. You have to manually feed it in using that data set $sign variable convention.
or you could select it, define it, and then carry it through the defined variable name.
Yeah. Keep it too.
And then you don't need to type as much.
Yeah.
Okay, so here's my command. When I run that command, this is the output. So the t statistic is minus 2.08. Does that make sense? To have a negative t statistic? Put 5.75 here instead. You know what we're doing now? We'd have 5.75. That's the question, the null that we're after. If this thing's negative, what does that tell you about your sample mean relative to the null?
Small.
It's smaller. And so where thus far I've always been going this direction, I'm now going this direction, right? It's a two-sided test. It doesn't matter whether or not I'm going to this tail or that tail. So the t-test can be negative here. And in fact, if I look, I can see that the mean in my sample of financial satisfaction is 5.71, so we know it's less than. And that's why this is negative. And now I get a p-value of 0.04. And if you have a alpha of 0.05, of 5%, you would then go ahead and reject the null. So the part of me that's a little concerned with that inference. And the fact is because we're using a two-sided test, my significance level, that 5%, has to be put into the two tails and can't be just put into one tail. So if I divide 5% by 2 and allow for things to be bigger or less than my null of 5.75, can I still reject? Cause I stepped into this problem saying, okay, my significance level is 5%. I don't know if things are bigger or less than my null. Otherwise, I would have specified my null, otherwise I would have specified my alternative in terms of a one-sided test. But I'm not here. I'm saying, I don't know if it's bigger or less. I just want to know if it's different. And so I'm taking that significance level of 5% and I have to put it into each of the tells. And that means that I split it in half and I've got 2.5 in the upper tell, 2.5 in the lower tell. And if I do that, 2.5, does that work to reject? It doesn't. Because if my 2.5 is here, well, here's F for 2.5. But that's telling me that my t-stat is here because it's giving me 0.375. So if I look at it from that standpoint, I would not reject. And that's something that you need to think through and understand. That makes sense? Okay, 2 sample t-tests. This kind of goes to this issue about are women taller than, or excuse me, are men taller than women? I've got 2 samples, sample of men, sample of women, and now I'm constructing a hypothesis test around that. And this is the case that we are having where we're not specifying that men are taller than women. So we have a 2-sided test where the one I wrote over there is a 1-sided test. So how do we really do this? I can go ahead and write things up there and show the equations and things like that. I don't think that's going to be very helpful. But what we need to do is really end up seeing whether or not there's a big difference between their sample means. And then factor and normalize it by their standard deviations of the 2 group. Okay. So let's do this in terms of financial status, the financial satisfaction rating. So there's a variable in there called group, and that will tell me if they're basically their gender. And as you look at these 2 histograms with the sample means, on average, are men more satisfied than women? So they are. So we might want to ask that question. Are men more satisfied than women from a financial standpoint by formulating my my hypothesis as my null hypothesis as average men is greater than average of women. And that means my alternative would be the opposite. That the average men would be less than or equal to the average of women. Any ideas looking at the histograms, what you might conclude? I don't have a clue. Because they're not that different, right? If I look at the dashed lines, is there really that big of a difference? I mean, what do you think that is? Close to 6? This is maybe 5.5. The distribution itself, got this craziness over here. Look at the counts. This is kind of peaked around the not as much variance. So let's see. We blur them over the top, yeah, it does seem to be that men are higher than women in terms of the distribution on financial satisfaction, how satisfied they're with their financial situation. Okay, so they're gonna go, in this case, I'm gonna start with them being equal, being a two-sided, and then we'll go to the one-sided after we get this one. So we're just gonna be rather closed-minded and just say, is there a difference between the financial conditions of men versus women? Is there a difference? And that's why we have this two-sided test. And that's pretty straightforward, right? Okay, we choose our significance level. We go ahead and compute the test statistic. And so how do we do groups? A two-group test statistic in R. Really nice, really clean, really simple. So we start with our dependent variable, which is, in this case, gonna be our financial satisfaction. And then we use the tilde command, which is up there under, but in the upper left-hand part of your keyboard above the downward apostrophe. Brian probably knows the name of that.
It's under the escape keys at the top.
No. There's a name for that apostrophe.
I call it a quote, yeah,
There's an actual name.
yeah, there is.
Quote hatch? Hash?
Yeah, there's a quote hash,
Quote hatch.
something like that, yeah.
No one calls it by its name.
Dude, we get this,
It's the thing by this is a tilde.
we know that.
That's a good point. So find the tilde, and then all you do is put in the variable name that has the grouping. And this is, in this case, there's only two types in that gender. I mean, excuse me, two types in that group. In this case, it's gender. All right, so we're looking at financial satisfaction, and then gender, which is men and women. There we go. And so there's the command that we would run. Notice I don't need to put a mu out here. Where before I had to do that, where I was using like mu is equal to 5.75, because in this case, I'm saying that they're equal. And so there's no value they're being compared to, they're being compared to each other. So that's all I need to do. And then I go ahead and, you know, once again, I need to think about my confidence interval, my p-values, my confidence level, my p-values and things like that, and then compute the thing. Why am I not away? I think I actually have this one computed in mind. If I can pull it up and run it for us real quick. So I've got everything loaded up here. Yeah, right there. See it? On line 56. So I've got my satisfaction level as being the dependent tilde on the group. In this case, it's gender. So let me go ahead and run that. See that, or should I move it? Let's do this.
How are you running the code?
little easier to see. And so when I ran that test as to whether or not this level of satisfaction by women and men, my T statistic is minus 15.227. So if I see that, I know what? That the women are less than the men. And I can see that down here where it says group 1 is 5.45, and group 2, which is men, is 6.02. And hence, when I take this mean, subtract out 5.45 and subtract out 6.02, this numerator is gonna be negative. When I normalize it by the standard deviations of the two groups, I am going to get a test statistic of minus 15. And the p-value is essentially 0. And so what would you say about that null of the level of financial satisfaction of women versus men? That women are not, you can reject that the level of satisfaction on men and women are the same. And it doesn't matter what the significance level you chose, that p-value is so small that you reject everything at 10, 5, 1, whatever percent, okay? Yeah,
So the code above that, that was just creating a frequency plot for men and women?
this one here,
Yeah.
yeah, do you wanna see that? So if we run that, it's gonna give me back
This
this table chart
Okay.
that just doesn't give me the graph, but it gives me the frequency for each of the level output.
on line 56, is that an equal sign?
That'd be the.
56 here,
It's on,
that's a tilde.
Okay.
Fingers are cramping. So in this case, you reject the null. And everything goes through. So let's go ahead and over the next 10 minutes, here are breakout session on conducting a one sample test on the case of financial risks, and another one in terms of what's your average level of financial risks relative to living in the Northeast versus not living in the Northeast. And in this case, this is coming out of that FINRA data. So before we're using the satisfaction variable, now we're using the risk variable. And the grouping is going to be the Northeast, which is the dummy variable 0, 1, where 0 is when you're not, 1 is when you are. In fact, I think that Northeast is actually a string variable. Okay. So everyone understand the two questions? So the first one is just going back to the one sample test statistic. And the second question is looking at the two sample test statistic and null hypothesis, okay? So think through what your nulls are going to be, think through what your alternatives are going to be, and then go through and code it and tell me what, and let's say at 15 after, we'll come back and talk about it, okay? Any questions? Right back.
Do y'all, this? I don't know, it's fun. So if we just did a two-tail test, what is the code for one tail?
It's on the next slide. You got it on the slide.
It was in the next. She goes in the next one. I can't, this is the part I don't like. I don't understand it.
It took me so long to get this any kind of message.
I didn't.
Y'all didn't get
I
this?
just memorized it.
She was
Yeah,
looking
like,
at us the
yeah.
whole time.
You people? No, I'm
I'm
kidding.
like, okay. And we were like, we don't get it. She's like, what do you not get? Okay, cool. I'm gonna just shut up.
I understood it but now. I
I
lost
did-
it.
Understood it in Chandri's class.
I understood
I
it
did,
for
'cause
the
we-
test.
Cause we had it in
And we took
In your
statistics,
project?
we had
Intro
took intro to
with
statistics
Dr.
before we took
Holmes.
econometrics. Like the semester
Oh.
before.
Oh,
Yeah.
intro
So-
with Dr. Holmes?
Yeah.
You learned it from her? What did
Y'all
you do?
didn't learn nothing
What?
from her?
I learned a lot from
Oh,
her.
so y'all learned a
I
lot
feel like
from
I
her.
learned,
We didn't learn.
she's a good
I
teacher.
think I might have taken it. Wait, which
We took
Holmes
a-
did you
we-
have it with? Sunny or Mary?
No,
Marianne.
There's
Marianne.
no way. We must have not been in the same class.
We
We
wasn't, we
We
took,
wasn't.
we took it last fall.
Oh, okay. I wasn't econ.
I think,
No, we
oh,
were in the same
really?
class with Alicia.
Yeah.
Yeah.
Our
that
take
was-
home finals.
Yeah.
oh yeah, we had those too.
Y'all didn't like her? I like to take home
loved her.
finals.
I mean,
I
one
loved
of them
her.
did take.
Yeah, I don't think
That's
she
right, but I don't think
teaches.
I learned anything from her.
That's my knowledge, but like.
What, we learned like probability and
All
stuff.
we learned was how to read the slide. The slide had the answer. I was like, oh, good job.
Okay,
Leah.
maybe she got better,
Yeah.
cause she was not like that, like, but she would like sometimes cancel class. She was not serious.
There's always like six.
Like you could turn in, like that folder, that binder
Oh, yeah.
Don't talk about that. It's too big.
that we only did, like, even though
We
class,
did it one time.
yeah, like we only checked it one time. I was thinking at the end of the semester, like, what did I get a binder for? She's very much not organized.
She's not.
It's very
That one
unserious.
thing they asked.
She is.
And then she'd be like, you know what, class canceled. I haven't used it.
Yeah, she will always, she canceled it because her Spelman sister had,
Oh, Dr. Cook.
she got inducted.
Oh, yeah. She got inducted
Okay,
into something
that's
that-
her.
The Federal Reserve.
The Federal Reserve one?
Yeah, the board, the
Oh,
governor.
yeah.
Oh, okay.
That's her Spelman sister.
Wow. I forget that sometimes they both went to Spelman. I'm like,
Me too. I forget that the other Sunny. I used to call her Sunny.
yeah.
I did not know
I
her
loved
name.
her.
What?
You don't like her?
I had her for math econ,
I had a
I
feeling.
got
That's
but it was a lot.
I think it was just the class, but I had a good time in math
The
econ.
whole deal with.
I like math
I'm-
though.
I'm confused. I like math too.
I like that
but
too,
The
but
staff that runs everything.
I was confused on how I got
That's
an A because I
math
failed.
econ.
I failed about 2 quick.
Math
Oh, that's-
econ is what I thought.
They're just-
Yeah, I thought, no, I just thought econ was like,
I
this
can
is
do
that.
I can do that.
Yeah, I could do it, but it
The
was
theory
just like,
classes, I don't like.
The
Micro
code?
theory and macro theory were backwards.
I like
Oh,
it
yeah.
though.
I didn't make
I'm
sense.
taking micro theory at Morehouse. They do math. Like they do a little bit of theory, mainly math on my lab.
But Stacey didn't have no math.
He said, it's pure theory. I said,
Yeah.
okay, I can get around it.
I don't know how I got out of that class.
I actually liked it.
No, it was a good class. He's a good teacher, but the exams,
Oh, no.
Who, Bisesa?
Yeah.
Didn't like him.
I liked him as a
He
person.
told me to drop the class.
Really?
Yeah.
Did you?
And then he quizzed me on the board. He's like, if you can answer these questions, you can stay. He's like, what's the partial derivative of up on the board? So he decided that I didn't have to drop it after.
I love that.
Ever
for
since
you.
then.
He loved like, okay, guys, who wants to come to the board?
Okay, that's how Rebecca was.
No, for real. She stayed asking us to come to.
I'm mad at Rebecca.
We should get those sliding whiteboards in.
I'm confused on how are you doing? So how's Dr. Tribble?
Terrible.
Do y'all get to work in groups?
No, we have to work by ourselves because it's over
And
2
then like they go like
semesters.
4 to 6.
Oh.
But we
Oh,
do, we
So
do
if
like,
you're not
like, way down
honors,
there.
Right.
you get groups?
Right.
yeah, you can.
No one
do
can
groups
see
now.
it. Well, I always like the
For senior
the
seminar, it's
sliding one, because
individual.
you could finish,
Um,
If you're honors.
put up there, and
honors.
keep it up there.
Everybody
and
does
just
it.
work on the side. If you have 3D.
I don't mind. I don't mind it being
Oh, you're in a group?
individual.
Is, okay, so all of
With
y'all
all the
honors,
stuff that you
that's
wanna
fine.
retain.
No, she's
No,
not.
no.
Shabaya.
You're not honors? You give honors.
Thanks.
Ain't got them give honors. No, I'm just kidding.
Hey, Shabaya, do you wanna make this an honors course?
Oh my
No.
god.
Absolutely not.
Immediately.
Do you-
No.
Would you need some honors credit?
No,
We've done it before.
I've already did all of my honors requirements except.
Oh, come on, an honors
Except
student's
social.
always an honors student.
It's over with after this semester. I'm finishing all my honors requirements.
If you put linear regressions into your project, I'll give you honors.
Mm-mm.
I did that, you're right.
I'm not even.
I'm gonna do it.
No, I do, I like regressions when we did it in state.
This is a little different. I feel like Stata is easier than this.
I think it's because we've been learning Stata
Stata
for
is
so
so
long.
unrealistic.
That's
They
why
don't- they don't use that.
All in all.
That's what I'm saying.
That's why Spellman makes me upset.
Why?
Sounds
We don't
like-
use
Like, we
it.
don't use the, where do you use Stata at?
Like,
So
Like,
did
we
you
use
go-
Excel or.
So-
Tableau.
Yeah, so
So do y'all have to, so y'all don't have to pay for state for the exams?
No.
For what?
Really? They provide it?
It looks weird.
I would think so.
No,
Like,
last year they did.
For senior seminar?
Yeah.
Sucks to suck.
but I think a lot of the seniors were in the like the econometric. Well, no, they weren't. I don't know.
I'm just trying to
Next.
make it to May 19th.
Great.
I'm trying to make it to. I'm trying to make it to the end of this semester. After
Okay,
that,
everyone, were you able to do it?
I did the one-sided test.
I think I did.
I did the first
So
two.
who wants to give it a try?
I could do the first one.
Okay,
So I picked the one-sided because there's only one thing we're looking at, and you're looking at the difference, so it would be like equal to or less than.
why, what would cause you to think that there's a logical argument around the null being less than?
Willing, different. The word different. Wait, what is that?
So that financial
Oh,
risk
no, no,
category.
no. It's not less than, it's either that, I mean, it's equal to or not equal to.
Okay, so that's a two-sided.
Okay, then.
Okay,
I'm
did you run it?
Yeah, but what I wrote is one-sided.
Are you sure?
Uh,
I bet you it's not one-sided.
For which?
For
For
what?
For
one?
the question number one. What, did everyone else do it like Taylor?
What did you write?
One side?
What's your null hypothesis in question one?
No, the average willingness to take financial risk,
H null equals
is it?
5.
the symbol
Uh-huh.
equals, I mean,
Yeah? Say it again, Leah.
The
You said just the word.
null
equal.
equals 5.
There you go. The null is that the mean is equal to
Okay.
5. That 10 doesn't, other than the fact that it's a rating, a ranking from 0 to 10, that 10 means nothing. So what does your command T dot test have in it?
T dot test FINRA $ FINRISK.
FinRisk?
I put mu equals 5.
That's right. And what did you, okay, and what did your output for this hypothesis? What did the t-test come back with?
True mean is not equal to 5. Oh,
What's
the
your
number,
t-test?
oh, 12.124.
That's the t-test. What's the p-value associated with that?
Less than 2.2 E minus
Minus.
16.
Is that what the rest of you got? So what would you conclude with regards to your hypothesis?
P-value is less than.
You would reject that average is 5. What is the average?
5.2.
5.2?
2.
So not very, not very, the difference in the means aren't that big. But that must mean that standard deviation is really tight. Correct? Anyone have questions about question 1? That makes sense? And you understand why the null and the alternative hypotheses are specified that way?
So this is a two-tap. This
No,
is,
that's the one.
This
This
is a
is-
two-sided,
Oh, it's two.
so why does it say one
It's a
sample?
one sample.
one
Oh,
sample.
yeah.
One sample, two-sided,
What's the sample?
one.
And risk.
Your fin risk, and we're not saying that we're not differentiating there to be different population means within, subpopulation means within the population.
Oh. so
A
it's
two
one.
sample would say, hey, I'm looking at financial risk, but there's 2 groups within that. So I'd have a sample here and I'd have a sample there, men, women,
Mm,
okay?
okay.
Whereas the second one is a 2 sample test where what are the 2 groups?
Northeast and not northeast.
And how did you conduct that test?
Mm.
Shavi?
You want me to tell you the code or like the null hypothesis?
You can do both.
Okay, so for the null hypothesis, I would say that is those who live in the Northeast. And then the alternative would be those who don't live in the Northeast. And then for the code, I did T-dot test, parentheses, FINRA _ clean $, fin _ risk. And then, what's that little thing called?
Tilde?
A tilde, FINRA _ clean $, Northeast. And for my p-value, I got 0.1715, which is greater than 0.05. So we would fail to reject the null hypothesis.
Very good. Hey, that's good because, no, I don't think I plotted that data. I applied that other data. So I couldn't tell from the data, but is there a significance level that you might not reject it? That you might reject it at?
1%.
What's the p-value again?
0.17.
0.1715.
So
That's 17%. Yeah, you want a lot of evidence against the null. Doesn't seem like you would really be stretching it, right? To reject the null under any significance level here. That what everyone else, Leah and Dion, that's okay? That works?
could you elaborate on the 17% again?
Writing on it. So when I was in college, I had one professor. And I swore I thought his house was just made with walls like this. So no matter what room he was in, he would be able to just write things down. I hope you guys don't think that about me. Okay, so. That's not good. So again, here's that normal distribution. Things are like right at 0. And Taylor's question was, what does that p-value of 0.17 mean, isn't it? So what was the t-statistic there?
Negative 1.3675.
The t-statistic was negative?
Yeah.
Yeah.
Say it again, negative one?
Negative 1.3675.
All right, so it's negative 1.3675. And the p-value that comes with that is this area under your normal distribution density. So that's my p-value.
I thought the p-value was greater.
Huh?
I thought the p-value was greater. Well, it is greater.
Let me just
So-
see what you guys.
The p-value is good. Yeah.
I thought the p-value was positive.
See if I can run that command so I got it. So there's a part that's got me a little confused.
You can't get that out.
So let me type it in here. My case, and all I'm gonna do is just grab it. And it's thin risk, right? That's,
Yeah.
Yeah.
okay, so there's the command. So let me just run it quick. Oh. And risks. All right, so you can see that. That's what you should have got, right?
Mhm.
Now what's critical here isn't the running, but interpreting it, okay? So you get this minus 3675. And we know that that's because the people in the Northeast have a higher financial risk average than non-Northeast people. Okay? And the p-value is 0.1715. And that would be what this area under here. Now, what would be a significance level that would allow you to reject?
0.05.
0.05 is 0.05. That would, if you give me an alpha of 0.05, that would be out here. In this area here, because we know that that's much smaller than that. Okay, my test statistic was minus 1.3675. Is that enough information or enough evidence against the null to reject it?
No.
Dion, did you?
I just feel like it wouldn't be any, because
It wouldn't be what?
because that's greater than 0.12, so like,
Oh, I know what you mean by any. This thing.
yeah.
It would never, I mean, there's just, this t-statistics p-value is so big, it really doesn't give us any evidence to reject. They're essentially the same number
So,
from a statistical context. They're saying they're not that this number is not statistically different from that number.
oh,
Does that
okay.
make sense?
So at what point would you reject?
So I would need to get a t-statistic that had a much smaller p-value.
Okay,
I mean, these are one and the same, they're like mirror images of each other. You know, this just tells you what level of significance you can reject at. And that's why, from my standpoint, in your projects, don't tell the reader that you're rejecting at a particular significance level without telling them the p-value, because that then allows the reader to then decide on their own, because they may have a smaller significance level that they need to have satisfied in order for them to feel comfortable rejecting the null. Okay, so good job on those questions. I think everyone, from what I can tell, it did a good job. Okay, so let's go back to this 2 sample test. R has 3 different ways that you can do a 2 sample test. The one that we just did, which has this tilde format, where you have the data that you're interested in computing, like height, the average height hypothesis, and then we have a dummy variable for groups, whether or not that's northeast versus non-northeast, gender, female versus male, whatever the case might be, you have 2 groups, and we're gonna show you how R deals with that in a second in another case. Or you could simply do another 2 sample test where you want to be looking observation to observation. So I've got height in January and I've got height measured in July. And I want to conduct a test to see whether or not those 2 are different from each other for each individual. And in that case, the test statistic in the t-test would be, say in this case, it would be the average in January minus the average in July. And then you'd have sigma January over n square root plus sigma July over square root of n. These are July and January. So it's different here. So what it's going to do is it's in this case right here, all it's going to do is it's going to take your variables, say y January for individual I and y July for individual I, and it's going to take the difference and let's call that xi, and that's what it's calculating. It's going to calculate that, the test statistic on that xi. How is that different than the third one? Excuse me, sorry. I just did the third one. How is that different than this one? 2. So the third one, you got x for the height and I, but I've got this paired equal true. And that's where I'm pairing it up, ith individual, and coming up with this new variable xi. How is that different than this one? Number 2 is this. number 3 is this. Any idea what the test statistic would look like here? You just take X sample mean. Because you're thinking about the difference of those two would be 0, and that would be the null, and then we have this underneath. And so this is very different than this. So 2 and 3 are that. We're gonna more be doing this going forward than we will be this third one. Okay, so those are the okay, let's get to these two-sided versus one-sided multi-sample test statistics. So when you're doing one-sided test statistics and hypothesis testing, you really have to think hard about your alternative and why that alternative is the one that you're interested in. You see that it's got the inequality sign rather than just that they're not equal. And then in the two-sample case, again, it's all about thinking about the alternative. And then once you set that, then the null sets up quite nicely. And you've got a diagram, that diagram that has the 4 different blocks that kind of shows this, but it's in text rather than in math symbols. And this is a really critical, statement. A one-sided test allows you to take a stand on the direction. And when you're taking a stand, that means that you have to have some reason for why direction matters. And so in my case of skill, if I say a mutual fund manager is skilled, that would mean that their performance, let's say mu, is less than 0. In other words, he doesn't give you as big a return. And the null is that he is skilled and that he produces above 0 return. So there's a reason for me to say this. So this is unskilled, because that and this is skill. And so what I want to do is I want to see if I can reject that null. But that is based upon the way that I've set it up. And that would be a one-sided test. And this is kind of, if you don't have a reason, don't do it. You have to have a logical reason for why you would do it. And this is where we're going to look at this case of intervention in a financial satisfaction, whether or not it helps you or hurts you. And so the null in this case is that no intervention is doing better than intervention. I don't like this alternative. I don't think it's the right way to think of it. You would think that's, well, maybe it's this, okay? What do you think intervention is from a financial standpoint? Say you're got a big credit card balance, and so you go and you try to have someone help you manage that. That tells you that your financial satisfaction was probably not too good to begin with, because you had to go find and get help on your credit so that you could overcome kind of your debt burdens. So maybe you only seek intervention when you need it because you're poor in your financial situation. So that would make sense, right? And so this null hypothesis would say, oh yeah, you need intervention. Hence, your financial satisfaction is probably lower than those who don't go and try to get help with regards to their financial situation. That makes sense? And that's kind of what you have to do, is you have to think through, and what's the argument for that, and then specify the null, and then in your project, kind of do what I just did in words, but in text. Okay, so this is pretty much the same thing, but in this particular case, this is one group. We're not distinguishing between men or women, we're just simply saying, look, we're just gonna think about it from a one group standpoint and make things easy. And this is how we do it. You put in the variable, which would be financial satisfaction here, and in this case, they put it that way. The null has it this way. A little puzzled by that. Maybe we're just spelling out. Yeah, I think what I'm doing is I'm just spelling out my syntax. So when you have a one-sided test, you come in and you have to specify what the alternative is. And whether or not it's a greater than, or whether or not it's a greater or a less definition in terms of the alternative. How can you make sense of this? What do you mean greater? What do you mean by less? So here's the way, this is the way R thinks about it. So if I go t-test x alternative is equal to greater. What that means is this. Go back to that distribution. Here I'm at 0. The greater means that it's going to go from the t-stat this direction. Does that make sense? What then would it be if I put less for that? So greater is saying greater than the t-stat. If I put less in here,
Less than a t-stat.
it would go that direction. Which do you want? Depends on what you're testing. But that's the way you can kind of think of it in your head as to, should I be using greater than, or I mean the greater alternative, or should I be using less? Thus far, a lot of the stuff was just greater. And it didn't really matter as much because we were using two-sided tests, but when we're using a one-sided test, it matters. So that you get that because this is gonna feed into the p-value, right? If I incorrectly put in less when I needed greater, what's gonna happen to the p-value? P-value is gonna be gigantic and give you the wrong inference. In fact, it's gonna give you the opposite inference if I have a low p-value for the actual test statistic and the hypothesis I'm after. Okay, so here's the particular alternative that says intervention decrease people's financial satisfaction. And in this case, the alternative would be that they would have a lower level of satisfaction as the alternative than the null. And is there enough to reject that null hypothesis? And notice which direction it is. It says that people's satisfaction is lower, and so we're moving in that direction, and that's why we have less here. And this is what that particular command would run. And so the p-value is 1, what would that tell you? There's no evidence here. In fact, what does the sample mean look like relative to the null that you're after? It's bigger, so it's going to push me in the wrong direction. In fact, the reason I'm asking a null about being this direction and my t-stat is over here. And so it's giving me all this less than. So in some ways, it's a little confusing why I would even ask this question if I looked at the sample mean. Right? If I look at the sample mean and I see that it's 5.896, why would I then say something along the lines of, well, is it less than? And so in this case, it's kind of ill formed. But that's how you would do it, and you specify the less as the context of the alternative. Here's another one with regards to test prep. And this is going to be a 2-sample test where we're looking at those who take a test and receive, before they take a test, they get instruction and tutoring and things like that through the test prep, and those that don't. And then how they perform on the test. And so this is going to be total score, and this is going to be group, where the group is either I received prep, test prep, or I didn't. Now, just step back and think about this to yourself. What do you think is test prep going to help you or hurt you on your test?
Help.
What's that?
Help.
Help. And so that should be your alternative. That the alternative is that prep helps you relative to those who had no prep. And so we would say, what's the sign going to be here? Greater than. And so that means my null is that prep is less than or equal to no prep. And notice how I started again with my null, where I say things through the context of reasoning in my null. I set the null, and then that shifts me to then specifying what my null, what my alternative, and then that pins down what my null is without even having to think about it. And that's what we see here. And then I'm going to run it. Now, in this particular case, I have to say, because it's a one-sided test, I have to specify what the alternative is. And that would be where I look here. And this makes sense because which one do you think has the higher mean? Those who had prep or those who did have prep? Who would you think?
Those who didn't have prep.
And so down here, it's saying, here's the people that didn't have prep, and this is their test score, and here's their average test score for those who did have prep, 2.09. Now, I go ahead and run this test. So scores, tilde, group, which the grouping is test prep or neither. So let me show you what the data looks like. You can see here's group here in this second to last column, and it's just a string. It says neither and test prep. So when I run that command, this is what I get. This is the output. My test statistic is 4.18, minus 4.18. My p-value is literally 1. But when I look at these, this p-value would say, no matter what level of significance you're willing to entertain, you're always going to find that you can't reject, right? You never get way out there in the tails. Does this match up with what you would expect? Remember what you said. You said prep should be helping students perform well on the test. Sure enough, it did, relative to those who didn't. But my test statistic is telling me that I cannot reject that. You look at these two numbers. You're telling me that 209 isn't significantly less than once. I mean, I don't see it. How in the world would I think that this could not be rejected? Or this is, I don't know if it's subtle or if it's intuitive. But my null says that this number should be smaller than this number. And it's not, right? Does it? And so why in the world am I not finding that my test statistic would reject this? So the problem is the way that R looks at groups in a 2-sample one-sided test. And it comes back to the way that it calculates it's the way that it calculates the t statistic, and then that will determine how the p-value is calculated here. So let me show you what it's calculated. You said that the test prep average score should be higher than the non-prep. Okay, so let's do that. Prep minus no prep. And that's gonna give me my t-stat. I got something down here and I'm not gonna worry about it right now. Given that the test prep average is 209 and the no prep is 168, is that number positive or negative? Positive. Why in the world is that thing negative? Okay, that's troubling. And so what R does is it doesn't care how you think about it in terms of the way you specified your alternative and your null. What it does automatically, it says, if you give me a group, you give me anything that has 2 groupings, and those groupings are by string values or characters, it's gonna order this calculation here in the t-statistic according to alphabetical order. And which one comes up first in the alphabet? Those who didn't receive test prep or those who did receive test prep? Who comes up first alphabetically? The ones that didn't. And so it on its own, just because of the way it looks at things, flips this around. And so you have to think about it in that context. Otherwise, you're going to make the wrong inference. So what do I need to do? Well, look at my distributions. They're symmetrical. I'm just gonna flip it over. And I'm gonna think, oh, the negative number is positive. So instead of a negative 4.1829, I'm gonna think of this as just, oh yeah, if I flip everything symmetrical, it's gonna be the opposite of that. And so that means I've gotta flip this. So leave everything else the same. All I need to do is flip this from greater to less. And if I do that, then I would make my integration this way. So I started this way, I thought it would be up here. But instead, I got a minus 4.183. And because I put in greater, I am now integrating this way. And that's where my p-value of 0.99 came from. But that's not the right thing. So what I'm gonna do is flip it. And all I have to do by flip it means you use less, not greater, for this command here. Does that make sense? We're kind of flying. That's all you have to do as long as you understand this. Because if I put greater than, because this is symmetric, under the less, I then integrate this way, which makes sense because things are symmetrical. So even though R worked out, everything is valid, it's just switching the order of my test statistic and how it's calculated. So as I put out in this bullet point here, it says it is always a good idea to verify what R thinks is group 1 and group 2 is the same things that you think is group 1 and group 2 in the ordering. And I know that I had a research analyst when I was years ago, and his code would run fine, and I go, did you check it? And he goes, well, the code ran fine. And I go, did you check it? And he would never check it. As long as the code ran fine and didn't have any errors, it must be right. And I just, yeah, that relationship didn't work very well. And so just really be thoughtful about what your results are telling you and whether or not they match up with your intuition. If I look at this, even down here, you can kind of tell how it's ordering the groups. It's saying that this one's first, and so that's the first population, that's the first sample mean in my t-statistic calculation. And this is the second. And so, yeah, no wonder this thing's negative. In fact, you can look at this and say, yeah, something's backward given the way that I'm thinking about this. So if I go ahead and I change the alternative from greater than less, then I don't have to worry about anything. And if I do that here, I find out that, again, the ordering's the same. Nothing's changed here. The ordering is exactly the same. But now instead of integrating from -4 to infinity, I'm integrating from -4 to -infinity because I'm going less. I get a p-value that makes a lot more intuitive sense, given that I know that my test prep average score is significantly bigger than my non-prep average score. And so just by changing that, I went from a case of saying, yeah, I'd never be able to reject the null, to one where it's hard not to reject the null, right? Things fairly small. And so that is one of the things with R in the group 2 sample one-sided test. Never a problem when you're doing 2-sided tests, it's only a problem when you're doing the one-sided test. See what else I have. I think that's it. There's also weighted hypothesis testing. What's there is when your sample isn't well representing your population. We're not gonna have time to go into that today. Hopefully, maybe we can do that next week. But I think everything else is probably relevant to your projects and the things that you'll be doing on it. Any questions? Like I said at the beginning, there's a lot here. We only introduced one command. So it wasn't a coding lecture. It was, how do you set up your hypotheses? How do you interpret that hypothesis? How then you make inference given the output from your t-test command, and making sure how you do that in both a 1-sample, 2-sided test and a 2-sample, 2-sided as opposed to 1-sided. That's really the 4 situations that you'll run into. Most of you will probably have a 2-sample test, because you'll be thinking about one group versus another group. Maybe kind of like in this situation where you have kids that took a prep class versus those who didn't, and whether or not it affected the outcome variable. Okay. Any questions? All right. No checkout question. I don't think I've got anything else.
Oh, I had a question about the project update.
For this coming week?
Yeah, I don't know if everyone feels the same way, but I just think we need more time, like.
Yeah.
today.
Make an argument, tell me why.
Well, I just know.
No, I know the why, just not only, make a proposal, tell me what's your proposal.
My proposal is Sunday at 11:59.
Say that again?
Sunday.
Is that, so that's the problem, I think, and I'm good with that, to tell you the truth. Because you got 2 things going at once, you got your homework, it's due on Thursday, then you turn right around, and then you walk into the class, right?
Yeah.
And you go, whoa, I just finished my homework last night, and now I'm in class, and then I've got to do my project update. And I think, I like that idea because it gives you Monday through Friday to do prep, and then also have time with the analyst and also with your economist. And that way you have all day Saturday and Sunday. So yeah, let's push it to Sunday at midnight, right? Yeah, I think that's, I guess when I originally did Saturday, I just don't want to kill your weekend. But you guys know how to, you're smart enough to figure out your weekends, right?
Yeah.
Yeah.
You're seniors, you guys are, wrapping it up. So let's do that, okay? Anything else?
Today. I'm gonna be on the road.
See you, Brianna, I'll record this
How are
and
you doing
post
in
it
the
on
class?
Canvas.
Right, 7 a.m.